Welcome back, guys. This is question 3.3 of chapter 3 of the book Electric Circuits by Nilsson, and the statement of our question is for each of the circuits shown in figure P3.3. okay, so this is the figure P3.3 and here we have figure A, B, C and D, and for it I have to identify the resistors connected in series, and B is simplify the circuit by replacing the series connected resistors with equivalent resistors. Okay, so here first of all let us identify that which one of them are the resistors which are connected in series with the other one. So let us start from part A of our question. So this is the figure 3.3a. Here we can see that we have this resistor, this one and this one, and in order to see that what are the resistors connected in series, if we can see that the current here is flowing through this one, so what are the resistors which are with it in such a way that the same current has been flowing through it as well. So the two resistors, if this is the resistor and the other one this one, these two will be in series with each other. If the current flowing through this one is I1, the same current will flow through this one as well. Okay, so these two will be in series if the same amount of current is flowing through it. Okay, so we can see that this is the current coming from this 18-volt source. It is going through this resistor at this branch. At this node it will be divided into two currents, this one and this one. So we can see that there is no resistors in which the same current is flowing as it is flowing through this one, so it is not in series with the other ones. So here we can see that this is the only resistor here, and there is also no resistor with it through which the same current is flowing. And the other current, this is here, this is the current which is flowing through the 5 kilo ohm resistor, and the same current we can see that will follow this route and it will flow through this 7 kilo ohm resistor. So we can see here that these two resistors 5k and 7k, these two are in series with each other because the same current has been flowing through it. Okay, so we can see that this and this, these two are in series with each other. Okay, similarly in P3.3b we can see that here this is the source, the current will be divided here through this one and this one. Okay, we can see that this current will be flowing through this 500 and will be here back. So the same current which is here is not flowing through the other resistors as well. This other current which is here is flowing through this 800 ohm resistor, and it will follow the same route, and the same current will flow through this 1200 ohm resistor as well. So we can see that this 800 and this 1200, okay, these two, 800 is in series with this 1200 ohm resistor. So these two resistors are in series with each other. Okay, so this current will come here and both of these currents will join here, and these two will flow through this 300 ohm resistor. Okay, so we can see that this current will be the sum of this current and this current, and this current will flow through this 300 ohm resistor, and the same current, we can see that this is the only way for this current to flow, and it will flow through this 300 and 200 ohm resistor. So we can see that this 300 and 200, these two are also in series with each other. Okay, so here again we can see that these two are in series with each other, and here these through 300 and 200, these two are in series with each other because these are satisfying the condition that to be in series with each other the same current should flow through the resistors. Okay, so this is basically the part B of my question. In part C we can see that this is the source which is here, and we can see that the current which is coming out of this source is divided into this and these two currents. This current when flow it is flowing through this 10 ohm resistor, and the same current will follow this route, okay, and will come back here. The same current is flowing through 10 ohm and 40 ohm, so these two are in series with each other. So we can see that this 10 ohm and 40 ohm, these two are in series with each other. The other current which is here, it is flowing through this 35 ohm resistor. The same current is flowing through this 15 ohm, and the same current is flowing through this 25 ohm. Okay, so therefore here this 35, this 15 and this 25, these three are in series with each other because the same current is flowing through these three resistors. So therefore these three are in series with each other. The last one here is this D. Okay, so here this current source is the primary source here, so we can see that this current will be here, it will be divided through this one and this one. So this is the only resistor here, and it will be here as well. Similarly here this current will flow through this 50 ohm, and then the same current will flow through this 90 ohm resistor. So therefore it satisfies the condition for the series. So therefore 50 and 90, these two are in series with each other. This current, when reach here, it will be divided into two currents. One will be flowing through this 100 ohm, the other one is 80 ohm resistor. This is the only one resistor which when will reach here, it will be divided. So there is no other resistor here through which the same current is flowing. Okay, while the other current, this one, is flowing through 80 ohm, and the same current will follow this route and will be flowing through this 70 ohm resistor. So therefore again here this 80 ohm resistor and this 70 ohm resistor, these two are in series with each other. Okay, so we can see that here we have seen that what are the resistors which are in series with each other, and we have seen that what is the condition here. So this is basically the solution for part A. In part B, simplify the circuit by replacing the series connected resistors with the equivalent resistors. So here what are the resistors which are in series? So these are 5k, 7k. So if the two resistors are in series, so in equivalent resistance, their resistances will be added together. So therefore 5k plus 7k, this is 12k. Okay, so therefore it will be what? Let me draw it somehow downwards. Okay, let me draw it somehow downwards. Okay, so this is A. So in A it will be this, okay, and there will be only one equivalent resistance, this one, and the value of it will be 5k plus 7k. These two are in series, so it will be 12k. Okay, this will be 6k, it is 8k, and this is the same 18 volt resistor. Okay, so this is for part A. In part B, this is for part B, the two resistors here are in series, the two here are in series. So therefore let me have it here, the 27 volts. Okay, so the first two resistors are 800 plus 1200. So 800 plus 1200, this is 2000 ohm. Okay, these two resistors, because these two are in series, so this is 2000 ohm. Okay, so the other resistor which was here was 500 ohm. Okay, these two are here. The other two resistors which are in series with each other are 300 and 200. So 300 plus 200 are 500. So it is here this 500 ohm, and this is what? This is now the equivalent circuit for this one. Okay, so this is the equivalent circuit. Let me move down somehow for the other two resistors. For part C, we have here these two and these two, the two parts, and in the middle we have this 90 volt source. So this is plus minus 90 volts. Okay, these two are connected in series, so the resistances of them will be added together. So 10 plus 40 is 50. So this is 10 plus 40 is 50 ohm, and the other, on the other side we have this 35, 15, 25. So these are here as well, and these will be added together. 35 plus 15 is 50, plus 25 is 75, so 75 ohm. Okay, so this is the circuit. Sorry, the polarity of it is here, this is minus and this is plus. Okay, this was a mistake, I have basically rectified it. Okay, so the last part is here, this one, what are the resistors in series? So 50 and 90, the first one. So the original source of current was here 30 milliamps. Okay, and the first resistor will remain unchanged because there is no resistor with it which was in series. The other two resistors, this 50 and 90, these were in series with each other, so equivalent of them will be 50 plus 90 is 140 ohm. Okay, and this, the resistor which is 100 ohm, it will be unchanged because no resistor is connected with it which is in series with it. And also the other two resistors here, 80 and 70, these two are also in series. So 80 plus 70, this is 80 plus 70 is 150. So this is basically the equivalent circuit which we wanted to find out. Okay, so that is what, that is basically the solution of question 3.3 part B. So that's it for today, in which we have solved question 3.3. If you guys have any question related to the solution of question 3.3, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.4 of our chapter 3 from the book of electric circuits by Nilsson. So the statement of this question is, for each of the circuits shown in figure P3.4, this is figure 3.4, and we have here A, B, C, D figures. So here we have to identify the resistors connected in parallel. Okay, so how would you identify the two resistors which are in parallel or not? So if the two resistors are connected in such a way that their two ends, if this one end and this other end, this is the first end of this resistor R1 and this is the first end of this resistor R2, this is the second end of the resistor R1 and this is the second end of the resistor R2. If these two are connected with each other, this is connected with this one and this one is connected with this one in such a way that you can draw them like this as well. Here you have other circuitry. So if this is R1, R2, one is connected with 1, 2 is connected with 2. So in this way the two resistors are basically in parallel with each other. This is the rule of thumb. If you remember this one, you won't forget that how would two resistors will be in parallel or not. Okay, so let us start it from part A of our question. Here we can see that this is the first resistor, this is the end 1 and this is the end 2. We can see that this end is not connected with these end of this resistor R2. Okay, if this is the first end, this is the second end, we can see that this second end is connected with this voltage source. So this 24, 36 are not in parallel. Similarly, this one and this one, this is the first end of this resistor, this is the second end of this resistor. We can see that these are directly connected with each other. Okay, means the one is shorted with 1, 2 is shorted with 2 and there is no other resistor in between them. So therefore 36 and 18, 36 and 18, these are parallel with each other. This is the sign of a parallelism and therefore 18 and 36 are parallel in this circuit A. Okay, in part B of my question, you can see that this is the first resistor. Okay, let me call 200. This is the first and this is the second one. This is the second resistor which is basically 120 ohm. So you can see that this is first, this is second. Here again these two ends and these two are directly connected with each other. So therefore 200 and 120, these are basically in parallel with each other. Okay, these are in parallel with each other. Similarly, if you can see that this is another resistor, this is the first, this is the second, and 280 is the second resistor, this is the first, and this is the second, and you can see that this end is connected with this one, this end is connected with this one. So therefore 210 and 280, okay, this 210 is in parallel with 280 ohm resistor here. Okay, similarly you can see that this 120 is not in parallel with this 280 because 120 has this 1 these 1 ends are connected with each other, while this 2 is not directly connected with this 2 because there is a resistor here. Okay, so therefore these two are not in parallel with each other. Okay, similarly you can see that this one is also not connected in parallel with each other because this second end is not directly connected with this one because of this 180 ohm resistor. Okay, similarly if you see this 120 and this 18, let us see it as well. Here you can see that this is the first end. Let me first remove them. Okay, so let me first remove them. And use this one. You can see that this is the first end, this is the second end, this is the first end, this is the second end. Okay, these two are directly connected with each other, but if you see this first end with this one, you can see that these are not directly connected, but there is a resistor in between them, so therefore these are not in parallel with each other. Okay, so you can here say that this 200 and 120 and this 210 and 280, these are the two combinations which are in parallel here in this circuit. Okay, which is of part B. In part C, let us again start it from this end. This is the resistor, this is the first end of this resistor, this is the second one, this here again, this is the first end, this is the second end, this is shorted, this is shorted, these are directly connected with each other. So therefore 75 kilo and 50 kilo, these are in parallel with each other. Okay, you can see it very clearly. Similarly here this 90k and this 50k, you can see that this is the first end, this is the first end, this is the second end of this 90k, but here this one is not directly connected with this other one because of this 60 volt source, and therefore these two are not in parallel with each other. Okay, similarly let me remove them here so that we can clearly connect them. So this is the other resistor here, this is the first end, this is the second one. Here you can see that this is the first one, this is the second one, and again you can see that if these are shorted, this is the first one, this is the second one as well. Okay, you can see that these one are connected directly with each other, these two are also directly connected with each other, so therefore 150k and 100k, these two are in parallel with each other. Similarly you can extend it and see that another resistor, this one of the 60k, is also shorted with these one, and these three are also shorted. So therefore from it you can very easily see that 100k is in parallel with 150k and this is in 60k, so means these three are basically in parallel with each other. So there are two combinations, this one and these three, these are in parallel with each other. Okay, so I hope you have understood that how to find out that whether the 2 or 3 resistors are in parallel with each other. First of all you have to see that how the ends are connected. So here again let us first take this resistor which is of 750 ohm. Okay, this is the first end, this is the second end. Again the 600, this is the first end, this is the second end. You can see that this first end is connected with this first one, while the second end is not directly connected with this two because of this resistor. Therefore these two are not in parallel. Similarly here for this 900 ohm, you can see that this is the first end, this is the second end. The two ends of this second ends are connected with each other, while if you see this first end of it, it is not directly connected with the first end of this 750 ohm because of this resistor. Okay, so these two 500 ohm and 900 ohm, these are also not in parallel with each other. Okay, you can see it very clearly here. Okay, so let me remove them again. Okay, and now let me use this red color for it. Okay, similarly, if this is the first and this is the second one, this is the first and this is the second one, you can see that this is directly connected, these two are directly connected. So therefore 750 is in parallel with this 500 ohm resistor. Okay, these two resistors are in parallel with each other. Let us start it from this these two resistors as well. So this is 2k, this is the first and this is the second end. Okay, and for the 1.5k, this is the first end, this is the second end. Okay, you can see that these are again not, the two same ends are not connected with each other directly, so therefore these two are not in parallel with each other. Okay, so similarly, this is the first end which is connected here, this is the first end, this is the second end. You can see that the two second ends and the two first ends of 1.5 and 3k, 1.5k and 3k are connected, so therefore these two are in parallel with each other. Okay, so these two combinations, these are basically parallel with each other. So I hope you have seen that how to find out the parallelism. Similarly, if you see this one, this is the first end, this is the second end, and if you see this one, this is the first end, this is the second end, you can see that the two ends are connected here, while the first ends are not directly connected because of this voltage or this resistor. So therefore 500 and 1.5k are also not in parallel with each other. The only parallel combinations are here and here. Okay, so that's it for today, in which we have seen the parallel combinations and we have to find out what are the resistors which are in parallel with each other. If you guys have any question, you can ask me in the comment box. See you soon. So this is question 3.4. Part B of it is simplify the circuit by replacing the parallel connected resistors with equivalent resistors. So as we have already identified the parallel resistors, let us solve them and find the equivalent of them. First of all, let me write the formula for the equivalent resistance. So the formula for it, let me write it by using this color. If there are the n number of resistors, so the equivalent resistance will be 1 over R1 first resistor, 1 over R2 second one, 1 over R3 third one, up to the nth resistor. Okay, 1 over R of n. Okay, so this is the formula we have to apply over here, here, okay, and here as well. Okay, let us first draw the equivalent of this part A. So the equivalent of part A is, it will be, this will be the voltage source, this will be the 24 ohm resistor, and the equivalent of it, because we can see that the total amount of current I naught is going towards it and it is divided in between these two resistors. So therefore this I naught is basically flowing through the equivalent resistor. Okay, so therefore it will be in series with this R. Okay, this R, and here it will be R equivalent. Okay, so the value of it is 18 volts. The value of R equivalent here would be, to find it out, it will be 1 over R equivalent, it will be 1 over 36 the first resistor, and the second which is in parallel with it is, that is 1 over 18. Okay, you have to find it out and then find the reciprocal of it, you will find the value of R equivalent. This is part A. In part B, we can see that the resistors which are in parallel are this one and this one. So therefore B, it will be the equivalent circuit of it will be here, as these two are in parallel with each other, so therefore it will be here. This will be, the combination of it will be in same style as it is here, so therefore it will be R equivalent. Okay, the other resistors, this is 280 and the other one is 180 ohm. Okay, so therefore this is what we have here. This is the current source of 30 milliamps. In order to find the value of R equivalent, here again it will be 1 over R equivalent, and the values of the resistors are 200 and 120. These are in parallel, so 1 over 200 plus 1 over 120 in order to find it out, and then finding the reciprocal, because you can see that this is 1 over R equivalent, you will find the answer of it. Okay, so this is for part B. In part C, you can apply the similar rules. Okay, in part C, you can see that here these three are in parallel. You can see that these three here are in parallel, and also these two 75 and this 50K, these are in parallel. So therefore, let me first draw the voltage source here. This is the voltage source of 60 volts. The other two resistors which are in parallel here are R equivalent 1. Okay, this is R equivalent 1. The other resistor is 90 kilo, which is connected here. Okay, and the three resistors which are basically in parallel with each other are also here. So it will be like this, and it is R equivalent 2. Okay, finding here the R equivalent 1, it will be 1 over R equivalent 1 is equal to 1 over 75 into 10 to the power 3, 75 kilo ohm. Okay, this is 75 kilo plus 1 over 50K, which is 50 into 10 to the power 3. Similarly, R equivalent to find the R equivalent to, it will be R equivalent to is, the three resistors are 100K, 150K and 60K. So 1 over 100 into 10 to the power 3 plus 1 over 150 into 10 to the power 3 plus 1 over 60 into 10 to the power 3. Okay, so this is, so by using these one, you can find out the R equivalent 1 and R equivalent 2. So these are here. Okay, similarly in the last one, this is part D, and to find the equivalent of it, let me move down somehow again. So you can see that these two resistors are in parallel. So the series resistors here would be, this is the first 900 ohm, this is the 600 ohm. Okay, these two are in parallel with it. Okay, you can see that these two are in parallel, so therefore it will be here. Okay, and that is, let me call it R equivalent 1. Okay, with it here the voltage source, and the voltage source here is negative positive, and here we have this resistor 2K. You can see that this is the 2K resistor, and the other two resistors which are again in parallel with each other, these are now in series with it, and let me call it R equivalent 2. Okay, so these are now connected like these one. Now in order to find out the R equivalent 1 and R equivalent 2, in R equivalent 1 you have to find the combinations of 506 and 750. That would be 1 over R equivalent 1, 1 over R equivalent 1 is equal to 1 over 750 plus 1 over 500, and to find out the R equivalent 2, these two are in parallel. So 1 over 1 into 10 to the power 3, 1.5K, and also plus 1 over 3 into 10 to the power 3. Okay, so this is for R equivalent 2, this is for R equivalent 1. Okay, so by using it you can find it, and by applying the same formulation you can see that what is happening here. One question is, why is it connected in parallel with this one, or in such a way that it looks like that it is in parallel with each other? Actually this R equivalent 2 is parallel with the combination of 600 and 900, but why we have connected it here? Because you can see that once the current enters through this node, you can see that it will be divided in these two, and the other current will flow through it. Similarly, you can see that all the current will flow towards this node, the current will be divided here, and the remaining current will flow through it. So it will not affect either we are connecting this R equivalent 2 here or the two resistors resistors in parallel here, therefore I have connected it like this one. Similarly, you can see that this is in series with this 2K. Why? Because the overall current which is flowing here and entering through this node will be divided among these two resistors. So therefore the total current which is going out of this resistor will be here, and it will be the similar one when combined the currents which are flowing through 1.5K and 3K. So that's it for today, in which we have seen the part B of our question 3.4. If you guys have any question regarding the solution of this one, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.5, and the statement of this question is, for each of the circuits shown in figure P3.3, this is figure P3.3. Here we have to find the equivalent resistance seen by the source. This is source, and what is the resistance or the equivalent resistance of the overall circuit which has been seen by this source. Okay, this is the source, it can see it from this way. So if it is seeing from this way, what will be the equivalent resistance? Similarly here, similarly here as well, here it can see it like this, and here it can also see like this. Okay, so we have to find them all, and in today's video we will try to solve part A for questions. Part B of it is find the power developed by the source. Okay, each of the sources we have to find the power developed by them. Okay, so in part A, this is the circuit, and here in order to find the equivalent resistance of the circuit we have to start from the very end. Okay, so this is the end, and here we can see that this and these two resistors, as we have previously seen, these are in series because the same amount of the current has been flowing through them. Okay, so for two resistors, if these are in series, so their equivalent resistance will be added together. Okay, so here if this is our equivalent 1, this resistance, so the resistance of it will be 5K plus 7K, this is 12K. Okay, and as we have seen previously, it is, this is the source, this is the resistance 8K. Okay, source is plus minus 18 volts. Okay, this is the 7 kilo ohm resistor. Okay, and the two resistors which are basically now connected in series, we have found out their equivalent resistance. This will be in parallel with it, and this is our equivalent one, the value of it is 12K. Okay, now you can see that the two ends of these two resistors are shorted. Okay, so which means that these two are basically in parallel with each other. In order to find the equivalent of it, that is R equivalent to, it will be 1 over R1 plus 1 over R2. Okay, similarly let us simplify it first because we will use it for all these circuits. So 1 over R equivalent to find the LCM of it, R1 R2, and here R2 plus R1. Okay, or the value of, if we will take the reciprocal of it, because this is now R equivalent to is now in the denominator, so R equivalent to is R1 R2 divided by R1 plus R2. Okay, so this is what we have. Taking it for this case where R1 is 7K, R2 is this R equivalent 1, which is 12K, what we will get, the R equivalent to here would be R1 is 7K multiplied by R2 is R equivalent to, that is 12K, and 7K plus 12K. Okay, so it will be 7K, 7 multiplied by 12 is 84 into 10 raised to power 3 into 10 raised to power 3. Okay, because these K will remain the same here and it will be 10 raised to power 6, but I am keeping them as it is. You will see that why I have done it in the next step. So here it is 7K plus 12K is 19K. Okay, so this K is basically 10 raised to power 3, so it will be, let me first remove it and then writing it as 10 raised to power 3 it is 10 to the power 3. These two will cancel out, and now 84 divided by 19. Let me find it out. 84 divided by 19, this is how much? This is 4.42 into 10 to the power 3, which is 4.42 k ohm. So this is what this is R equivalent to, and what is it look like? Let me move down somehow. It will be, this is the circuit, this is what, plus minus 18 volts. Okay, here we have the resistor, which is 8k. Okay, and these two resistors we have found out their equivalent, are equivalent to, here this is the R equivalent to, and the value of it is 4.42 k. Okay, now you can see that these two resistors, this one and this one, these two are in series because the same amount of current has been flowing through them. So therefore the R equivalent here would be what? It will be like, this is the resistor and the R equivalent, which is the only resistor here. I am calling it R equivalent. It will be 8k because two are in series, so 8k plus 4.42k, it will be 12.42k, and this is for R equivalent, and here the value is 12.42 k ohm. Okay, this is in ohm, and it is 18 volts. Okay, so this is the equivalent resistance of the overall, which can be seen by this source. Now the second part is to find the power which is supplied by this source. Okay, so now this is the source, this is the resistor connected with it, but for this source, in order to find the power, we have a formula which is P equal to IV. We don't have the value of current here, and the value of current here is I is equal to V divided by R. Okay, now let me take it and put it here. So P will be equal to V divided by R multiplied by V, so it will be V square divided by R for the source as well. Let me put their values. So V is 18 whole square divided by 12.42 into 10 to the power 3. Okay, so let me calculate it. It will be 18 square, how much is it? 324. So 324 divided by 12.42. okay, so this is 26. So this is basically the power here is, let me write here the power generated by this source is how much? That is 26 into 10 to the power, this is minus 3 because here it is now in denominator, and when it will be moved to the numerator it will be minus 3. It is watt, or we can write is like P is equal to 26 milliwatts. Okay, so that is what, that is basically the part A and part B for this circuit which we have seen. Now in part B of it, we have this circuit, these two resistors, taking them because these are in series, the same amount of current has been flowing through them, so therefore it will be 1200 plus 800. Okay, if I can write them here, this is plus minus 27 volts. Okay, so this is what, this is the equivalent resistance made by these two, and the upper one is this 500 ohm. Okay, 1200 plus 800, that is 2000 ohm. Okay, and the other two resistors are here. We can see that these two are also in series, the same amount of current has been flowing through them. Okay, we can simplify each of the series resistors here if these are in separate branches, because it doesn't matter whether these are in the same branch or in this other branches, and also it doesn't matter whether we find the equivalent of them initially or at the end. Okay, so therefore I have been taking this 300 at 200 ohm and adding them together, and it will be 500 ohm because these are in series. So the simplified circuit is now here. Now I can see that these two ends are connected with the other two ends. Okay, so these are in parallel with each other, and in order to find the equivalent of it, as I have shown you, the equivalent one of it will be, that is R1 R2 divided by R1 plus R2. I have proved it earlier on, and now putting their values. So R1 is 500 multiplied by 2000 divided by 500 plus 2000 is 2500. Okay, so now let me find them out. It will be 500 multiplied by 2000, okay, divided by 2500, it is 400. So this is now 400 ohm, and you can see that in parallel the dominant resistance is the lowest one, while in series circuit the dominant one is the highest one because it dominates in the equivalent value. So you can see that this is 400, which is closer to this lower one, and in series you would have seen that this is 2000, which is closer to this highest one. So therefore in series the highest resistance dominates, while in the parallel circuit the lowest one dominates. Okay, so this is the R equivalent, and here if we simplify it further, it will be this, and these are now simplified. Okay, so this is now R equivalent 1, and the value of it is 400. This is now 500. Okay, and this is the simplified circuit, 27 volts. Now these two are in series, and simplifying it and getting the equivalent or the final resistance from it, these two will be added together, because in series the resistors, the value of the resistances are added together. So it will be 400 plus 500 is 900 ohm, and the value of it is 27 volts, and this is the resistance which is seen by this source. So the R equivalent for it is 900 ohm. This is the solution of part A of my question. In part B, as we have seen previously, the value of power is V square divided by R. The value of V is now 27 whole square. The value of R is 900. So finding it out, it will be what? 27 square. Okay, so this is 729 divided by the 900, it is 0.81 or 810 milliwatts, and that is basically the solution of part B of my question. Okay, so now here this is the source, and these are the resistors connected with it. So as we have previously seen, here we can see that this branch is composed of these two resistors, which are basically in series because the same current has been flowing through them. Similarly, we can also see this branch as well. Here these three resistors, 1, 2 and 3, the same current has been flowing through them. Okay, so therefore these are in series, so we can add them and them together. Let me call these resistors or the equivalent of these resistors as the equivalent one. So R equivalent 1 is 35 plus 15 plus 25. So this is 35 plus 15 is 50 plus 25 is 75 ohm, and R equivalent 2 is, here these two resistors are in series, so that is 10 plus 40, which is 50 ohm. Okay, so these two resistors. Now the equivalent circuit will be like this one, these resistors, which are basically the equivalent resistance composed of these two resistors. So therefore this is the R equivalent 2, and here this. Okay, so this is what, this is the R equivalent 1, which is composed of 35, 15 and 25 summation. So here this is we have, and this is the source, and the source is of 90 volts. Okay, you can see that here these 2 points, these 2 points and these 2 points. Okay, let me change the color of them as well so that you can see them clearly. So these points, these are shorted together, there is no other source or any other passive element here. Similarly, these 3 points, you can see that these are also in parallel. Okay, so therefore I can also draw them as this is the source. Okay, and the resistors connected with it are this and this. Okay, so these are basically the resistors. This is the R equivalent 2, this is the R equivalent 1, and this is the source 90 volts. So these resistors, these are in parallel. Why I have changed the position of this source to this, and how is it possible to change it? Because these 3 are in parallel, so any combination in parallel will be valid. So therefore I have changed it to this one. So therefore now these 2 R equivalent 1 and R equivalent 2, these are in parallel with each other. So therefore R equivalent 1 is in parallel with R equivalent 2. So therefore the equivalent resistance of it will be R equivalent 1 multiplied by R equivalent 2 divided by the R equivalent 1 plus R equivalent 2. Let me put their values. So R equivalent 1 is 75 multiplied by 50 divided by 75 plus 50, which is 125. Okay, so here it will be, let me simplify them. So simplifying them, this is 25 375, 25 5 125, so 5 10 here. So this is now 30 ohm. So now let me call it R equivalent, and that is 30 ohm, and if I can draw it from here, it will be the R equivalent of it will be, this is the R equivalent, which is 50 ohm, sorry, which is 30 ohm as it is, and the value of it is plus 90 volts. Okay, you can see that this is the solution of part A. In part B, as we have seen it that here in this series circuit, the power supplied by this source is equal to the power absorbed by this resistor. So therefore, in order to find the power of it, we have to use the formula which is previously shown, that was V square divided by R equivalent. Let me put the value of it, that is 90 square divided by 30. So if you calculate it, you will get the required power as it is here. Okay, I will solve part D of it, and previously we have seen that how to simplify the circuit composed of the combination of different resistors which are connected in series and in parallel. Today we can see that here we have this circuit, and we know that in order to find the equivalent resistance seen by the source of the circuit, we have to start from the very end of the circuit. Okay, so here let us start it, and here we can see that if we consider a current which is flowing through both of these resistors, which are 80 ohm and 70 ohm, it can be seen that the same current has been flowing through them. If the same current has been flowing through them, according to the condition, these two resistors are in series. So therefore the resistances of both of these resistors will be added together, and here what we will get, if I can solve it like this, so this is a source, this is a 300 ohm resistor, the two resistors which are here 50 and 90, I will come back to it here as well again. This is the resistor 100 ohm, and the two resistors 80 and 70, these will be added together. So 80 plus 70 is 150. This is 150 ohm. Okay, these two are now here connected, and here these are. We can also see that these two resistors, if a certain amount of current has been flowing through this 50 ohm resistor, this same current will be flowing through this 90 ohm resistor as well. So therefore the resistances of both of these resistors will be added together. So 90 plus 50 is 140. Okay, so this is 140 ohm. You can see that this is the initial simplified version. Here both ends of this 150 ohm resistor are connected to the both ends of this 100 ohm resistor. So according to the condition, these two resistors are in parallel with each other, and in order to find the equivalent of both of them, what we will have to do, we have to 100 multiplied by 150 divided by 100 plus 150, because the R equivalent in parallel resistors is R1 multiplied by R2 divided by R1 plus R2. This is the formula. I have applied it here, and here applying it, what will I get? 100 multiplied by 150 is 15,000. Okay, and divided by 250, this will be cancel out, and 1500 divided by 25 is how much? Let me calculate it. So 1500 divided by 25, this is 60. Okay, so the equivalent of it is 60, and if I can write it like this is the source, the same source, with it in parallel the 300 ohm resistor, then 140 ohm resistor which I have got, and the equivalent of the parallel resistors 100 and 150. So the equivalent of it is 60 ohm. Okay, so this is now the next version of this circuit, and the current source here we have is this 30 milliamps. Okay, so again considering another current which has been flowing through 140 and 60 ohm resistor, the same amount of current has been flowing through them, and the current is also the similar one. So therefore both of them are in series. So in series the resistances will be added together. So 140 plus 60 is how much? That is 200. Okay, and these two ends are connected with these two ends. Okay, you can see that the equivalent ends are connected with the two ends of this 300 ohm resistor. So this is 300 ohm, and here we have this 30 milliamps source. Okay, now these two, we can see the two sides or the two ends are connected directly with each other according to the definition. These are in parallel with each other. So applying the same formula, what will I get? It will be 300 multiplied by 200 divided by 300 plus 200 is 500. Okay, so let me simplify it. So 300 multiplied by 200, that is 60,000 divided by 500. Okay, so that is 120. The equivalent of it is 120 ohm. So therefore the equivalent resistance, let me go down. So here this is the source of the 30 milliamps, and with it the connected resistor is the equivalent one, and that is this 120 ohm resistor, and that is the final result which we wanted to find out, the part A of our question. In order to find the part B, to find the power consumed by the resistor or the power supplied by this source, because only a single current source, only a current source is connected with this resistor. So therefore in order to find it out, here the power will be VI. Okay, so as we have I and the current is unknown. Okay, so therefore V is equal to IR, this is what we have, multiplied by I. this is what, this is the voltage across this resistor. So we will get here I square R. Let me put values here. So I is 30 into 10 to the power minus 3 whole square multiplied by 120. So finding it, you will get the power which is required. Okay, so that is what, that is the formula for finding the power, and that is the solution of part D of my question. If you guys have any query regarding the solution of part D, part A, part B, part C, you can ask me in the comment box. See you soon. Welcome back, guys. So this is question 3.6, and the statement of this question is for each of the circuits shown in figure P3.4. so this is the figure P3.4, in which we have sub figures which are A, B, C and D. For it, we have to find the equivalent resistance seen by the source, and B is find the power developed by the source. So we have to do it for each of the circuits as we have done in question 3.5. okay, so here we will find the equivalent of the each of the combination and then write it here. For each of the equivalent, I am going to use a separate color. So first, here for part A, we can see that we have to start it from the very end. Therefore, here we can see that the two ends of these two resistors are connected directly with each other. So therefore these are in parallel. So therefore 36 is in parallel with 18. okay, so when it will be, we will get the equivalent of it. That would be what? That would be in series with this 24. so therefore it will be 24. okay, so here what will be the output here? The output circuit here, I am going to draw it with this color. So the output circuit here will be plus minus. Here it will be this R equivalent. okay, and this is 18 volts. The R equivalent resistance is 24 plus 36 in parallel with 18, because with this equivalent this will be in series. So finding it, so it will be 24 plus 36, 18 parallel combination, it will be 36 multiplied by 18 divided by 36 plus 18, because in parallel the R equivalent resistance will be if R1 and R2 are in parallel. So the formula is R1 plus R2. This is derived from what? This is derived from the 1 over R equivalent is equal to 1 over R1 plus 1 over R2 if the two resistors are connected in parallel. So from it we have found it out. Here it will be 36 multiplied by 18 divided by 54. Here it will be 3 here, what? 3 12 36. okay, this 24 plus 12, that is 36. okay, and this 36 ohm is this R equivalent. okay, so this is what? This is the equivalent resistance here. okay, so this is what? This is the solution of the part A of my question. In part B, let me first remove all of these. Here in this circuit, starting from the very end, we can see that these two resistors, these are basically connected in parallel because both of these are connected here directly. So therefore 210 is in parallel with 280. okay, so these will be in parallel. Once we will find the equivalent of it, this is the equivalent, it will be connected with what? Here this is what? This is 180 and it is in series with this 210 is in parallel with 280. okay, so it is what? This is 120 ohm, this one. So we can see that the same amount of current has been flowing through them. So therefore the output of it, or the combination of them, will be in green, and it will be what? It will be 180 plus 210 is in parallel with 280, and with it we have another resistor, this 120. okay, this is here. okay, the other resistors with it are this 200 this 200, this 120, and then the source. This has been solved. So we can see that here the two ends of these two resistors are what? These are in parallel with each other. Okay, we can see that these are connected directly, so therefore 120 and this one is in parallel with each other. Similarly, this is also in parallel with it, okay, because all of them are basically parallel and all three are connected directly. So therefore, in order to find the equivalent of it, let me use the red color for the equivalent of it. For these three, we will have this red color, and in order to find the R equivalent of it, what it will be, the first resistor is 1 over 200, the second one is 1 over 120, and the last one here is this one, that is 1 over 180 plus 210 is in parallel with 280. So this is what we have. Okay, now simplifying it and finding the output, it will be 1 over R equivalent, it will be 1 over 200 plus 1 over 120 plus what, this 1 over 180 plus 280. So 210 multiplied by 280 divided by 210 plus 280. Okay, once you will find it out and then find the reciprocal of it, R equivalent will be found out, and it will be what? It will be, this will be here, this is the current which is 30 milliamps. Okay, and with it this R equivalent will be in series, which is here this calculation. You can find it out and give the answer here. So this is your task to calculate it and give me the answer. So that's it for today, in which we have seen the solution of part A and part B today. If you guys have any query regarding the solution here, you can ask me in the comment box. See you soon. Welcome back, guys. So this is question 3.7, and the statement of this question is composed of two parts. In part A, in the circuits in figure P3.7, this is P3.7 figure A to D, find the equivalent resistance seen by the source. These are basically the circuits, and here we have to find the equivalent resistances. And B, for each circuit, find the power delivered by the source. Okay, so once you will find the equivalent circuit, which will be like this one, okay, and it will be composed of a single resistor which is R equivalent, and here this source, either it can be the voltage source or a current source. Here you can see that these are basically the voltage source, and these two are the current sources. So by applying the formula P equal to IV, okay, you can find the power here. Okay, because this will be a single source and a single resistor here, so the power supplied will be equal to the power consumed. Okay, so here either you can put I is equal to V by R, or if there is a voltage source, so there you will put V is equal to IR. Okay, and from it you will have to find the powers, and powers will be in the form of the consumed power across this resistor. So those would be P is equal to I square R, or P is equal to V square divided by R. You can use any of these formulas here for the power. Now as we are here, we will find the equivalent resistances. Here in this circuit, you can see that in part A, both of these are shorted, so these are in parallel with each other. Both of these points are also shorted, so you can see, so you will see the equivalent of them, and here 45 is in parallel with 30, and here this 15 is in parallel with 60. Okay, so once you will find it, it will be like this is 25, the resistance here is 50. Okay, this is what, this is the 10 ohm, and this is the R equivalent one, which is the 45 is in parallel with 30. This will be the equivalent of it, and here it will be the equivalent of 60 and 15, which is 15 is in parallel with 60, and here this resistance, what, this is 20. Okay, now these three are in series. You will have to add them together. You have to find the equivalent of them by using the formula. R equivalent of this parallel is R1 multiplied by R2 divided by R1 plus R2. Okay, and then add them together. What you will get will be in parallel with this 50, and then at the end all of these resistors will be in series. Okay, this will be the solution of this circuit, which is in part A. So after it, you will get a circuit where you will have a single voltage source of 30 volts. Okay, and P is equal to V square R. By applying it, you will use the R equivalent, what you will get, and the voltage will be here 30 volts, and from it you will get the power which is supplied and then consumed across this R equivalent. So this is part A. Now in order to move to this part B, which is the actual question which we are going to solve today, let me first remove all of these. So now here let me use this red color, and in this circuit, this is part B. Let me start it from the very end. We can see that these two ends and these two ends of these are basically connected directly. So therefore 20 and 60, these are in parallel with each other. Okay, also if you can see this end here, if the current is flowing through this circuit, so the current which is flowing through 18 ohm and 12 ohm is the same current. So therefore 18 and 12, these are basically the series resistors. So 18 plus 12, this is 30, and this is the equivalent resistance which will be here. Let me draw it here. It will be like this one, and here this resistor which is here, and another resistor which is this. So 60, this one here, and here this another one is 30. Okay, and with it the connected resistor is this 75. Okay, you can see that it is just like this one, and this is the short one. Now if this is 30, you can see that both ends of this 60 and 30, you can see these two are connected with each other. So therefore these two are in parallel with each other. So therefore the equivalent of them is R equivalent 1. This is R1 into R2, this one. So 30 multiplied by 60 divided by 30 plus 60, which is 90. Okay, so this would be the 1800 divided by 90. This will be cancel out, and here 20. Okay, so the R equivalent is 20 ohm. Okay, you can see that it will be here, and these are basically what this will be. It will be, now you will see that this equivalent, which is this 20 ohm. Okay, and that would be, now the equivalent of them is 20, and this is basically the resistor here which is now in series with this 30, and here the other connected resistor is this 75. Okay, so now 20 plus 30, this is now 50. Okay, so this 50 and the other circuit it is here, so this will be the 50. This is in parallel with 75. Okay, this 75, you can see. Let me clear this one as well. Okay, so 50 and 75 are connected in parallel. So when these two are connected in parallel, let me use the same formula. It will be R equivalent to, this is 75 multiplied by 50 divided by 75 plus 50, that is 125. So this will be here 25, 5 the 125, and that is 2, and 75 multiplied by 2 is 150 divided by 50 divided by 5, so 5, and this is 30, so it is now 30 ohm. Okay, so now the equivalent resistance here is this 30 ohm from all of these loop. Okay, so now as we have also made them like this and also found the equivalent of it, so equivalent of it, as these two are in parallel, so this is our equivalent 3, that is 20 multiplied by 60 divided by 20 plus 60, which is 80. So 24 and 4 15, so this is now 15 ohm. Okay, so now this is 30 and with it we have this 15 ohm. Okay, with it the connected resistor is here, which is now 50 ohm. This is 50 and also the other resistor here is with it is 20. Okay, you can see that these are the resistors and with it this 40 ohm. Okay, so now you can see that the same current has been flowing through this 30 and 20, so therefore these two are in series. So when these two are in series, the resistances will be added together, it will be 50 and it will be here, and the other resistor is this 50 as well, this is also 50. Okay, and these are here also, the other two resistors are 15 and here we have this 40. Okay, this one 40. Now you can see that both ends of these two resistors, let me change the color, let me use this color, blue one. So the two ends of these two resistors 50 and 50, these two are basically connected directly with each other, so these are in parallel with each other. So once you will find the equivalent of two same resistance which are connected in parallel, it will be half of any one of them. You can also use it here, so let me prove it here as well. This is, let me call our equivalent 4. So our equivalent 4, the two resistances are 50 multiplied by 50 and 50 plus 50, this is 50 multiplied by 50 divided by 100. Okay, this is 2 and you can see that this is 25, which is half of any one of these resistors. So therefore it is now what it is now, this is 15, the equivalent of them is 25. Okay, and the other resistor, which is this one, this is now what, this is here 40 ohm. Okay, with it the source is connected, so therefore these two are in series. So 15 plus 25 is 40, so let me draw it here. So this is now 40 ohm, this resistance here is, okay, this source here is 80 milliamps, this is the current source, and with it this 15 plus 25, these are in series, so these are connected, so 40. So you can see that again these two are in parallel. So using the same condition, and we have what we have proved here, again we have two resistances which are same in the values, so the equivalent of them will be the half of any one of them. So this will be here and it will be only one resistor, which is 20 ohm, and this is what, this is 80 milliamps, which is here. Okay, so this is what, this is the equivalent resistance of this, where sorry, this is the equivalent circuit of this B, where our equivalent is 20 ohm. Okay, and in order to find the power which is provided by this 80 milliamperes, that would be P is equal to I square R. Let me put the value of I, which is the same one as it is, and R is R equivalent. So I is 80 milliamps is 0.08 square multiplied by R equivalent, which is 20. So once you will calculate it, you will get the answer of this power. Okay, so that's it for today, in which we have seen the solution of part A and part B. We are going to solve part C of it. So here we have to find the equivalent of this circuit, and in part B we have to find the power delivered by the source. Okay, so let us first go through it. So here we can see that these are the 2 points, and if the current is flowing here, you can see that the same current has been flowing through 500 and 2.5 kilo ohm. Okay, so then these two are in series with each other, therefore I can draw it like this. Okay, This is basically the circuit, and here 500 plus 2.5k, which is 2500 ohm, so it will be 3 kilo ohm. Okay, now taking these 2 points and here, okay, and the other two resistors are, this is the 750 ohm resistor, and with it this is another resistor, the source, and another resistor. These are here. You can see that the 2 points of these resistors, which is the 1 kilo ohm and 3 kilo ohm, these are connected with each other, so therefore these are in parallel with each other. So therefore finding the equivalent of them, it will be the R equivalent of it will be R1 multiplied by R2 divided by R1 plus R2, taking one of them R1 and the other one as R2. So the R1 is 1 kilo multiplied by the 3 kilo divided by 1 kilo plus 3 kilo is 4 kilo ohm. Okay, these two will cancel out and it will be 3 by 4 kilo ohm. Okay, so this is what, this is the R equivalent one, which is here. Okay, similarly this end is now what you have seen. So this is 3 by 4 is how much? That is 0.75 kilo ohm, or it is now 750 ohm. Okay, so this is now the 750 ohm, this is this one. So taking it here, this is the equivalent here, the other resistor which is 750, this one, this is with it here, and this is the R equivalent of all these. Okay, so this is again 750. Okay, and the source plus this resistor plus source plus another resistor, these are here, while this is the other side of the circuit. And if I combine them, what I will get here, it will be 750 plus 750, because these two are in series with each other, so it will be 1500 ohm. Okay, this is the resistor, this is this source and another resistor, and it is what we have. The value of this resistor is 250 ohm, the value of this source is 20 volts, and this is the 3 kilo ohm resistor. Okay, you can see the other side of the circuit. Let me see what is it. So this is 300. Okay, and this one with it, this one, okay, this is 2 kilo ohm, and these two resistors, you can see that again these two, the same amount of current has been flowing. Again this is 1.8k and 1.2k. this is what, this is how much, this is 3 kilo ohm, so this is 3 kilo. Again the 2 points of these are connected with each other, so therefore let me go down somehow. So here we can see that 3 kilo and 2 kilo ohm. Okay, these two are in parallel, so R equivalent to this is 3 kilo multiplied by 2 kilo divided by 3 kilo plus 2 kilo, that is 5 kilo ohm. This will cancel out, and here we will get 6 kilo divided by 5. So 6 by 5 is, let me calculate it, 6 divided by 5, this is here, so that would be 1.2 kilo ohm, 1.2 kilo ohm. So this side, this is now here 1.2 kilo ohm. Let me redraw it. So redrawing it, I will get here 1.2 kilo ohm. This is now how much? Let me see it again. This is 300 ohm. Yes, 300 ohm. And here we have this resistor which is 250, this one, the source, this one which is 20 volts, and another resistor which is 3 kilo ohm. Okay, these are here, and on the other side of it we have this 1500 ohm. 1500 ohm. This is the simplified circuit. You can see that the two resistors are again in series with each other, so therefore it is now 300 plus 1.2 is again 1.5 or 1500 ohm. you can add them, 300 plus 1200, so you will get 1500. And here this 250 ohm, this source plus minus 20 volts and 3 kilo. Okay, these are here, and this 1500 ohm. This is the circuit which we have got. Now you can see that these three branches are in parallel with each other. Okay, these are the three branches and these are in parallel with each other. We can arrange them in any order, and in taking them, let me keep this branch on the leftmost end, and then keeping them together, this 1500 and this 1500, what I will get, this will be 250 ohm. This is the source plus minus, and this is 20 volts, and again this 3k. Okay, and this 1500 and the other 1500. Okay, this is what we have. Now the two same resistors are connected in parallel with each other, so therefore the equivalent of them will be the half of any one of them. Okay, so therefore the equivalent of them will be 750. I have proved it in the previous videos as well, that if the two resistors are similar in value, let me try it here as well. So our equivalent, if R1 is equal to R2 is equal to R, so R1 multiplied by R2 divided by R1 plus R2, if this is the formula, so it will be R multiplied by R divided by R plus R is 2R, so this will cancel out and it will be R by 2. Okay, so now here it will be 750 ohm. Okay, so 750 ohm, and this source, this resistor, another resistor. Okay, and the equivalent of it will be here, it is now 750 ohm. Okay, now this is plus minus 20 volts. The same amount of current has been flowing through all of them, so this 250 ohm, this 3000 ohm, okay, or 3k ohm, these all are in series with each other. So finding the equivalent resistance of all of it, I will have to add 250 plus 750 and plus this 3k, which is 3000. So what will I get? I will get 4k ohm. So the equivalent resistance and the equivalent circuit here, and that is 4k, and the value of it is plus minus 20 volts. So the answer or the equivalent resistance is 4k ohm. Okay, now in order to find the power of it, we know that P is equal to IV, as this is the same situation in which the power supplied is equal to the power dissipated by the resistor. So therefore now taking this voltage, which is the same one, and the current, so therefore here it will be V square divided by R. V square is 20 square and R is 4k. So this would be, here you can solve it and you will get the answer of it. Okay, so that's it for today, in which we have seen the solution of the part C of my question, which is here. Okay, if you guys have any question regarding the solution of it, you can ask in the comment box. See you soon.